Like, share, subscribe.
Hey y'all, welcome back. Number 52. It says if y equals 8x squared plus 4x minus 1 is expressed in this form, this is actually called vertex form, where hk is the vertex, where a, h, and k are constants. What's the value of k? So this is vertex form is what we're trying to get it into, and we are trying to go from standard form to vertex form. And to do this, we are going to use a technique called completing the square. Now, I'm just going to go through this one problem, so you're really only going to see one example of me completing the square. But if you're a little bit confused about the steps I'm taking, or you just want to see more examples, this would be a good thing to kind of look up, online, either search it on a search engine or here on YouTube. Just Google completing the square examples, and you could see a lot more examples going from standard form to vertex form. So if we start with standard form, we've got y equals 8x squared plus 4x minus 1. We want to complete the square here so that we can convert it to vertex form. So the way to do that is first, you're just going to kind of group your first two terms here, okay, and leave that minus 1 kind of hanging out by itself. Okay, so now to complete the square, to get it into that vertex form, you can kind of see I'm starting to get it into this form. Look, I've kind of separated off a constant here. I need to add something inside here to make this a perfect square trinomial, and that way I can factor it, and so it can look like this x minus h squared. Before I can do that, though, I do need the coefficient of that x squared to be 1. So I need to factor out the 8 as a GCF, or a greatest common factor. It's kind of like doing the distributive property, but in reverse. So I'm going to factor out that 8, and I'll have x squared plus, and then 4 divided by 8 would be 1/2. So 1/2 x. I haven't really changed anything, but you can see I'm slowly starting to get it into this form. Now the trick here is knowing what to add inside those parentheses so that you make this, you force it into being a perfect square. So we just kind of copy the original thing. There we go. And so, like, what do we want to add here? So to figure out what you need to add here, I'm going to call this the b term. Okay, so I'm going to say 1/2 is b. Right, this is like a, b, and c. Or, you know what? Forget it. I'll just call it 1/2. The way to come up with that number is you're going to take whatever is the coefficient of the linear term, okay, in this case 1/2, you are going to divide that by 2. Okay, so whatever it is, you divide it by 2, and then you square it. So this is going to get a little messy because we've got a fraction here, but we are going to square this entire expression. Okay, so like usually it's easier if this is a whole number. Like let's say it was like 6. 6 divided by 2 would be 3, and 3 squared would be 9, so you'd put a 9 here. We are dealing with a fraction here though, so no big deal. We just need to kind of figure out what that equals. So 1/2 divided by 2, well, if you cut a half into half, you get a fourth. So you get 1/4, and we need to square that. And whenever you square a fraction, you're really just squaring both the numerator and the denominator separately. So 1 squared is 1, and 4 squared is 16. So the number that we want to put here is going to be 1/16. Now, unfortunately, we can't just add whatever we want to this equation. Otherwise, we're effectively changing the equation. So we have to sort of balance this out by subtracting 1/16 as well. Now, so if I write this, now I'm adding 1/16, I'm subtracting 1/16. I'm not actually changing anything, right? These would just combine to be 0. I can add 0, that's fine. But what I really want to do is I want to move this minus 1/16 outside the parentheses so that the only thing that's left in here is that perfect square. Now, if I just go ahead and move this, this is going to be a crucial error here. This is not going to be correct because I didn't actually add 1/16 here. I wrote 1/16, but what I really added was 8 times 1/16. This 8 is still on the outside of the parentheses here. And 8 times 1/16 is actually 8/16, or that would reduce to 1/2. So I'm really just adding 1/2 here. So what I really want to do is I want to subtract that 8/16. Okay, that would correctly balance it out if I take this on the outside of the parentheses. So now I have a perfect square here, and I can go ahead and factor that. And the way the factoring is going to work on this is, well, it's always going to be x plus whatever that original number that you had, in this case 1/2, was divided by 2. So in other words, like this first step before you square it, that's going to be the number that's inside the parentheses. So we're going to have x plus 1/4 squared, and then this minus 8/16 minus 1, minus 8/16, that's really minus 1/2. 8/16 reduces. So if I have negative 1/2 minus 1, I can combine those. 1 is 2/2. So I get negative 1 minus 2 is going to be minus 3/2. Whoops, going to scroll down erroneously there. So this will just be minus 3/2. And so now we've converted it to vertex form, which is really the whole point of this. Trying to get it into that vertex form. It's asking now, what is the value of k? That's that constant out here. So our answer here is going to be letter C. Okay, it's going to be this minus 3/2. But again, if you want some more practice with completing the square, definitely search for some more examples of how to do that. It does take a little bit of practice to really kind of, commit to memory the steps on how you would actually do that. So that's it for number 52. I hope you all enjoyed the video, and y'all have a great day.